Today in Capechi's Corner, we're going to look at the Pythagorean Theorem. The Pythagorean Theorem states in a right triangle, the square of the hypotenuse is equal to the sum of the square of the legs. So if you look at our diagram, our C value, that's our hypotenuse, it's across from the right angle, and our legs are A and B. So the theorem states A squared plus B squared is equal to C squared. Now, this theorem only applies to right triangles. Now let's practice some. The directions say to find the value of x. Now again, the Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the hypotenuse. So in number 1, my value for x is a hypotenuse. So I have 4 squared plus 6 squared, because they're the legs. Doesn't matter which one I write first, is equal to x squared. So 4 squared is 16, plus 6 squared is 36, is equal to x squared. Now 16 plus 36 gives us 52, is equal to x squared. Now I want to know what the value of x is, not x squared, so I'm going to have to take the square root of both sides. Now if this were an algebra problem, I would need a plus or minus in front of this root 52, but because we're talking about geometry and we're talking about a length, I know that my value has to be positive, so I don't need that step. So in simplifying 52, it's not a perfect square, but I know that the square root of 4 goes into it, so I have the square root of 4 times the square root of 13 is equal to x, so I have 2 root 13 is my value for x. In looking at number 2, again, I'm going to use the Pythagorean theorem because I have my right triangle, so I'm going to say 7 squared plus x squared is equal to 10 squared. So this time my value for x is a leg and not the hypotenuse. 7 squared gives me 49 plus x squared, and 10 squared is 100. Now I'm going to subtract 49 from both sides, so I have x squared is equal to 51. Again, take the square root of both sides, and I also have to remember I need a positive value because a length can't be negative. There is no perfect square that goes into 51, so I'm just going to leave that in simplest radical form that states x is equal to the square root of 51. Now number 3, again, I have my right angle here, so I know that this is my hypotenuse, so I'm going to say x squared plus 6 squared is equal to 12 root 3 squared. Now the algebra is going to be a little harder on this one, but again, the Pythagorean theorem is going to be the same, so I'm just going to work with it and simplify. So I have x squared plus 6 squared is 36 is equal to, now this is 12 root 3 times 12 root 3. So when I simplify that, let's do that again. X squared plus 36 is equal to 12 times 12 gives me 144, and root 3 times root 3 gives me 3. So I have x squared plus 36 is equal to 432. I subtract 36 from each side, and I have x squared is equal to 396. Take the square root of both sides, and 396 is not a perfect square, but I do know that 36 goes into that, so that's my highest perfect square I can work with. So I have x is equal to the square root of 36 times the square root of 11, so x is equal to 6 root 11. And looking at number 4, I have x squared plus the quantity of x plus 2 squared, and my hypotenuse is 10, so it'll be 10 squared. So I have x squared plus, now that's x plus 2. It's just as easy to rewrite it, and I know it's a binomial times a binomial, so I'm going to need to use FOIL. 10 squared is 100. So that gives me x squared, and again I'll use FOIL, so I have x squared is my first. My outside is plus 2x, my inside is plus 2x, my last is plus 4 is equal to 100. I'll combine my like terms, so I have x squared plus x squared, that gives me 2x squared. And then I have 2x plus 2x gives me plus 4x. Plus 4 is equal to 100. Now remember, anytime I have a variable with the second power or higher, I'm going to bring everything to one side, so I'm going to bring this 100 to the other side by subtracting. So I'm going to move over to the left a little bit here. I have 2x squared plus 4x minus 96 is equal to 0. Now I can factor out a 2. It's just going to make my numbers a little bit easier to work with. So I factor out a 2. That's my greatest common factor. I have x squared plus 2x minus 48 is equal to 0. Now I have to try to factor it. Again, my signs are opposite because I have a negative here. I have an x and an x. Factors of 48 that when I subtract, I get to 2. That's going to be 8 times 6. I need 8 to be positive because that's positive. So there we go. 2 times the quantity of x plus 8 times the quantity of x minus 6 is equal to 0. Now as I continue the problem, I know that x plus 8 has to equal 0, or x minus 6 is equal to 0. So x will equal to negative 8, or x is equal to positive 6. Now again, if I look back at my diagram, I have one side has a length of just x, so I know that it can't be x is equal to negative 8, because that would be a negative value. So I know my final answer for x is 6. So if I go back to my sides, I can say this side has a value of 6, and this side has a value of 8, because I have x plus 2 and x as a value of 6. In problem number 5, I'm trying to still find the value of x, but I have kind of a different shape. I notice I have some right angles. So if I bring my side down right here, I've made myself a sort of a rectangle. And if I know my bottom value here is going to be 7, but my top value here is 4, right here I can see it's 4, then I know that I can make some adjustments. I can use that. Now because I have a 4 here, I know this is 4. I know this whole piece is 7, so that's going to make that side 3. Again, I came down as an altitude, so that's a right angle. Because I know this side is 3, I know this side is also 3. So again, I can use the Pythagorean theorem. So I can say 3 squared plus 3 squared is equal to x squared. So I have 9 plus 9 is equal to x squared. So I have 18 is equal to x squared. Take the square root of both sides. Square root of 18 breaks down to the square root of 9 is my perfect square times the square root of 2 is equal to x. So I have 3 root 2 is my value for x. Now in our last problem for today, it says find the length of the diagonal of a square with perimeter of 16. Well, I know a square has right angles everywhere, so I'm going to mark that right away. And the perimeter says it's 16. I know a square has 4 equal sides, so that means all my sides are going to have a value of 4. Now I'm looking for the diagonal, so I'm going to make that x. And again, I can use Pythagorean theorem. So I have 4 squared plus 4 squared is equal to x squared, which gives me 16 plus 16 is equal to x squared. So I'm going to take the square root of both sides. 32 is not a perfect square, but 16 is, and that goes into it. So I have square root of 16 times the square root of 2 is equal to x, which gives me 4 root 2 is my value for x, which is my diagonal.